What superpowers are needed for reality manipulation on a universal scale? Luckily, you only need two. You need to be able to manipulate space-time, and you need to be able to manipulate the way that quantum particles interact. These are the two areas of science that aren't connected right now: quantum mechanics and relativity. Everything is governed by these two sciences. If we had a grand unified theory, then you'd only need one. You'd have to be able to manipulate whatever we figure out in the grand unified theory. But since these two are still separate and still don't agree with each other, those are the two powers you need. And in fact, every superpower is just a derivative of these two powers. And the ability to manipulate the elements like fire or electricity, that's just manipulating particles. Teleportation is just linking 2 points in space-time. Even probability manipulation, which I said before is a scam, that's just altering the results of quantum interactions, particle manipulation. Any knowledge power, like reading someone's thoughts or seeing the future, is just taking information from a point in time and downloading that into your brain, which is made of particles. Everything that exists is just mass and energy, which is made of quantum particles, and the where and when of how they exist is governed by space-time. Literally any superpower, even the wonky superpowers from like JoJo's Bizarre Adventure, can be made with these two superpowers. And any other superpower you could think of is just some combination of these two superpowers with extra limitations. Yes, even the ability to manipulate concepts. So yeah, you want to bend the universe to your will? You only need to bend the building blocks of it, of which there are only two. Get those two superpowers and you're already well beyond a god. Sure, I don't mind going over this one again. There are only two superpowers because there are only two areas of science that don't really agree with each other yet. And that is relativity and quantum mechanics. Quantum mechanics deals with what things are. They deal with particles. They deal with the lowest units of existence. If you wanted to change something's fundamental properties, you would be altering it on a quantum level. Relativity describes how things move through both space and time. Relativity describes everything we see very well. So does quantum mechanics, but they don't jive with each other yet. And so any superpower you have is doing one of those two things, or both of them, with whatever limitations you want to put on it. The Flash, that's relativity, space-time manipulation. He gets to ignore the laws of physics and go as fast as he wants. The Thing, quantum manipulation. His body is made out of rock. Magneto, he controls magnetism. That's a force that uses energy, which is mediated by force carrier particles, which are quantum objects. So that's quantum mechanics again. Jotaro can stop time. That's relativity. And no matter what superpower you think of, even if it's something crazy like concept manipulation, its effects are always going to be one or both of these two things. Like, think about mind control, right? Your brain is made up of matter and energy is made up of quantum particles. So everything that makes up your mind is just matter and energy interacting with each other. So if you could manipulate that matter and energy, you could manipulate a mind. If you have luck manipulation, whatever is being manipulated by your luck is either a feat of manipulating quantum mechanics or a feat of manipulating relativity. Even if you get into like the weird stuff like soul manipulation, if you just ask, what is this thing doing? Then you're going to get something that can be described by either quantum mechanics or relativity. So if soul manipulation lets you bring someone back from the dead, you have basically altered all the matter and energy in their body such that they are living again and thinking and breathing and so on and so forth. That's just quantum mechanics. Or if you rewind their time locally to a point before they were dead, that's relativity. So in the end, there are only two superpowers, and to get whatever superpower you want, you just put limits on these two superpowers. So limits on superpowers can basically be described as a lack of knowledge or influence across either quantum mechanics or relativity. I mean, yeah, basically. The reason why I have this series of videos saying that there are only two superpowers is to kind of get at how each science leads to another. Like, there's this old saying, psychology is applied biology, biology is applied chemistry, chemistry is applied physics. And if you ask a mathematician, they'll say physics is just applied math. All of our scientific fields of study basically go from more abstracted to less abstracted. Like a cell in biology is made up of atoms and molecules which interact with each other, and atoms and molecules are made up of individual particles that interact with each other. The cell is biology, the atoms and molecules are chemistry, the particles are physics. When people write comics or anime or anything like that, they're not thinking of these things. This is basically a way to show how far back we have gone with science. Like, if you look at stuff and you say stuff is made out of atoms and atoms are made out of particles and so on and so forth, eventually you get down to quantum mechanics. But then if you go in the opposite direction and go to the really, really big you get relativity. Relativity is the stuff that governs gravity and the way celestial bodies move, and how light moves across our universe. And those two models very accurately describe the world around us. It's just that they don't play very well with each other. A lot of people in my previous videos said this is a boring way to look at superpowers, and I'm not saying that I necessarily look at all superpowers this way. My channel is basically about tying scientific concepts into the fiction that we know and love. But I'm thinking about superpowers as if I were looking at anything else in science, right? Like if you look at a flower, then you could zoom in and see a cell, and then zoom in and see atoms, and zoom in and see particles, so on and so forth. I've already said this like 3 times. So I'm thinking to myself, if you're looking at the superhero that has the ability to control fire, right? And you zoom in, ask yourself what's happening. If they are somehow creating the molecules and atoms that create fuel that ignite out of nothing, that is, at its base, quantum mechanical. If you look at another superhero who is, I don't know, slowing down time in a bubble, if that space-time is curved and that's why it slows down, then that is relativistic. But the person with fire manipulation can't, like, do other sorts of quantum manipulation. Like, even though fire manipulation and, I don't know, water manipulation are both quantum mechanical in nature, I don't expect someone with fire manipulation, like a firebender from Avatar, to be able to bend water. Like, that doesn't make sense in terms of the story. Hell, I'm not even saying that they could, I'm just saying that they have the same scientific root. The same process, if you can imagine superpowers having a process, is happening. The fundamental particles and forces in our world are being changed, and that's quantum mechanics. And if the fabric of space-time is being changed, then that's relativity. And make no mistake, the only reason why these are the 2 superpowers is because we haven't found the grand unified theory yet. We haven't found the thing that ties quantum mechanics and relativity together. When we do, there will only be 1 superpower, with however many limits you want to put on it to create the exact superpower that you want. Couldn't all superpowers just be boiled down to particle manipulation? No. I know you said teleportation is just quantum entanglement, but not really. That's not really how entanglement works. And remember, interaction breaks entanglement. So you can't really teleport something with quantum entanglement. You can't even really teleport info with quantum entanglement, not the way sci-fi makes it seem you can. Quantum entanglement just means that when 2 particles interact, the state of one is dependent on the other. Or rather, we can infer things about the state of one particle by the state of the other. If 2 electrons are entangled and one is spin up, we can infer the other is spin down. But we can't change the spin of one and then have the other one change. So yeah, you can't teleport with quantum entanglement. It's just not possible. And until we find the grand unified theory of everything, you're going to need 1 superpower for everything that deals with relativity, and 1 superpower for everything else. If you like my videos about science and comic books, give me a follow and check out my sponsor in the link in my bio. It really helps me out. Is being super intelligent the closest we'll ever get to real life superpowers? Well, I'm gonna be a little bit pedantic here. If it's something that we can actually do, it's probably not a superpower. There's nothing super about it, because we could do it. But there's plenty of examples. There's eidetic memory, like you said. There's people who are double jointed, so they're super flexible. People who can withstand extremes of temperature. And of course you have strong men who could, like, pull buses. I mean, all human ability is going to be distributed among the curve. Go to the extremes of those curves, and you get what you might call superpowers. But again, we can do them, so there's nothing really super about them. They're just the best of human ability. Would Superboy's tactile telekinesis be quantum mechanical manipulation when you think about the model of there only being 2 superpowers? I would say yes. Because first you have to think about what it means to move something. There are 4 fundamental forces. You have the strong nuclear force, the weak nuclear force, electromagnetism, and gravity. Now, gravity, that mostly is dealt with relativity. We're putting that aside. But those other 3 forces all have force carrier particles associated with them. So when you push or pull something, when you grab something, when you lift something up, you are dealing with those first 3 forces. I mean, honestly, you're really just dealing with electromagnetism. That's the thing that makes atoms repel each other, and that's why my hand doesn't go through my head. So applying a force to something is basically quantum mechanical in nature. I mean, if we figure out the grand unified theory, it may turn out that everything is quantum mechanical in nature. In fact, that's the thing we're hoping for. But from what we know right now, those first 3 forces are quantum mechanical in nature. So if Superboy's tactile telekinesis is basically like applying a force to lift something up through telekinesis, that is going to be dealing with those first 3 forces. If Superboy's tactile telekinesis was like bending space-time to cause an attraction from one object to another. That would be relativity, but then we would see a whole bunch of wonky stuff happening. Like, you'd see time dilation anytime you pick something up, and since you don't see that, I think it's pretty safe to say that his tactile telekinesis is quantum mechanical in nature. Your superpower is Higgs field manipulation? Well, I hate to break it to you, you probably aren't that powerful. While it does give particles their fundamental rest mass, most of our mass doesn't come from Higgs field interaction. It comes from the strong nuclear force. It comes through quarks interacting. So just being able to manipulate the Higgs field wouldn't even allow you to, make yourself massless and make you move at the speed of light. Nor could you really arbitrarily increase someone's mass, because again, very little comes from the Higgs field. You certainly do some wonky stuff. Like, if you can make light interact with the Higgs field, you could probably create Green Lantern-style light constructs. Of course, you could fuck people up by messing with how much electrons interact with the Higgs field, but it's not nearly as powerful as you think it is. It's just important. You really want to start ruining days, manipulate the strong nuclear force. I'll be doing another video on that soon. How far can you push the strong nuclear force as a power? Pretty far. The strong nuclear force is responsible for most of the mass in the universe. So you can control things' mass, which can control their gravity. You can control what particle things are made of. You could amplify that force to create new matter. You can make particles attract each other with a force far more powerful than gravity. Again, I'm gonna say this, if you are a superhero who has control of one of the 4 fundamental forces, you're already broken. That's why they're called fundamental forces. They are fundamentally what makes up our universe. You control any of them and you have matter manipulation, energy manipulation, limited space and time manipulation. But the strong force is the strongest out of all of them. You would need very little matter or energy to do anything with the strong force. How far can you push magnetism as a superpower if you take all of science into account? Honestly, Marvel Comics has already done it. And he's called Magneto. Electromagnetism is one of the 4 fundamental forces. Sure, it lets you levitate metal, I guess, but it also lets you just control electrons. That's like matter control. It lets you control electricity. It lets you control subatomic interactions. Frankly, if you could control the subatomic particles in any piece of metal to make them magnetic, you could do that in literally any material. And for that matter, basically stop someone's biological processes. Anything that could be boiled down to a fundamental process of the universe is busted. So for that matter, gravity is also busted. It's less busted because it's the weakest of the fundamental forces, but if you can increase gravity without increasing mass, snap your fingers, black hole. Snap your fingers, time dilation. Snap your fingers, white holes and wormholes. Gravity is the curving of space-time. If you could arbitrarily control gravity, you could arbitrarily control space-time. Fundamental forces are busted. Explain why gravity is the least busted of the 4 fundamental forces to have as a superpower? Sure, watch me defy gravity. I'm doing it right now. I'm defying gravity with my hand. That's the gravity of an entire planet, beaten by little old me. Meanwhile, a very small amount of electromagnetism can do all this. Light my house, power your phone. And the strong nuclear force is so powerful that if you take 2 subatomic particles bound together by it and pull them apart even microscopic distances, it dumps so much energy into the system that it creates new matter. If gravity was your superpower, you would have to make immense changes to gravity, expend immense amounts of power to do stuff that electromagnetism or the strong nuclear force or the weak nuclear force could do relatively easily. Gravity is actually the weakest of the 4 fundamental forces. It's cool because of what we casually associate with it, but it is very weak. Again, defying the gravity of a whole planet. So I made a video explaining why gravity would be the least busted of the fundamental forces to have as a superpower. And I want to make something clear. I'm not saying that gravity would be useless. Any fundamental force as a superpower would be really powerful. It's a fundamental force. It's just that gravity, by the numbers, is the weakest by magnitudes. In this comment, you said, if you could increase or decrease gravity at a local level, you could rip someone apart or crush them, right? So I want to put this in scope for you. If you just held someone over the surface of a planet, the gravity of Jupiter would not rip their arm off. The gravity of the sun would not rip their arm off. To get to that scale of doing bodily harm, we're talking about the gravity of black holes, some of the most powerful black holes that we know of in our universe. So you have to take gravity to its extremes to do anything. And yeah, that's cool, but it's still its extremes. Meanwhile, there's enough energy in the strong nuclear force and the interaction between 2 quarks to create new matter. You separate the quarks enough and so much energy is dumped into the system that new particle-antiparticle pairs are created. If you could freely harness that energy, there would be enough energy to atomize you without even using all of your atoms. I mean, again, think of it this way. You would need the gravity of a black hole to, like, tear someone's arm off, but we can just make electric engines that can tear someone's arm off. That's just electromagnetism, harnessed by science, no superpower needed. Anything gravity can do, the other forces can do with far less investment. Like, yes, the gravity of a black hole can crush you into a singularity. If you were able to harness the strong nuclear force of every particle in that black hole, you could do the same thing. You could crush someone into a singularity probably countless times over. And, like, this is just scientific fact. We've measured these forces. So, like, I get it. While gravity has cool factor, if you're asking which of the fundamental forces is the strongest, gravity is the weakest. Could you move stars with gravity? Yeah, but you can also move stars with any force. And on its scale, you would need less electromagnetism, say, to move a star than gravity. Because remember, it's black holes that are moving stars, the most extreme limits of our universe. You don't need to go to those extremes for any other force. You'd have to go far beyond what we have now, but you don't have to hit those extremes. This is kind of a psychology thing. We think big means strong. We've seen gravity act on huge scales. But if you think about it, photons are electromagnetic radiation, and we've detected them as far back as the cosmic microwave background. Electromagnetism literally from seconds after the Big Bang. So, like, that has scale too, we're just not thinking about it as much. So yeah, sorry. Gravity as a superpower pales in comparison to the other fundamental forces. People still don't like that I called gravity the weakest of the fundamental forces. Like, look, in a superhero context, yes, manipulating gravity is incredibly powerful. Again, manipulating any fundamental force is powerful. However, we're assuming that there's some sort of limit, right? Like, if a superhero could manipulate gravity without limit, the universe is over. Like, he's completely unbeatable. There is something that we assume limits these superheroes, some sort of exertion, some sort of power reserve, right? In which case, if you could finitely manipulate gravity, you could do more by finitely manipulating the same amount of the strong nuclear force. Like, if we take whatever requirement there is to manipulate a certain amount of gravity, and we say that would normally require X amount of mass, but the superhero could just do it with his super batteries. We have now established a mass to super battery relationship. A certain amount of mass's worth of gravitational effect is worth this much power that the superhero uses. Cool? Cool. Now here's the thing. You could produce similar effects with much less mass using something like the strong nuclear force. Which means that if we've created a mass to superpower battery relationship, a superhero that uses the strong nuclear force would use less of his power to do more stuff than the person who manipulates gravity. Because the strong nuclear force is, by definition, scientifically stronger than the force of gravity. That's not an opinion, that's just a scientific fact. And I know that it muddies the water when you're talking about fiction, because you can make people in fiction do whatever you want, right? But if you have two superheroes, one which can control gravity, and one which can control the strong nuclear force, and they both have equivalent power reserves, the one who controls the strong nuclear force is going to be able to do more. Again, by definition. People have often commented, well, if you could control gravity, you could control space-time. Yes, and do you have any idea how much mass it would take to do that? You are outputting a godly level of power to be able to manipulate gravity on that scale. Cool, we've created a godly being. If you had a godly being with the same amount of power manipulating the strong nuclear force, he could do more. Including time dilation, because the strong nuclear force is where the majority of mass comes from. So you just get gravity powers via strong nuclear force powers. But you don't get strong nuclear force powers via gravity powers. Like, this is all a goofy discussion because we're talking about superheroes. But, like, the facts are facts. The strong nuclear force is more powerful than gravity. We've measured it. The only thing I could say about gravity is that it acts over very long distances. But so does a strong nuclear force, just in a different way. It drops off very quick. And if you could forego the mass requirements for gravity, you could forego the distance requirements for the strong nuclear force. And the strong nuclear force still wins. Shadows don't exist. Or at least they don't exist as, like, a tangible object. They're an idea. A shadow is just where photons aren't. I mean, you see this shadow of my beard on my t-shirt? Photons of light from my ceiling light are shining down on my face and hitting my beard. And some of those are being reflected off my beard or absorbed into my beard as heat, and they don't make it to my shirt. And the places where they don't make it, the shirt is darker, and that's what a shadow is. So shadows aren't made up of anything. They are explicitly where things are not, specifically where light is not. This, by the way, is when people ask me what would controlling shadows do as a superpower scientifically. I say nothing, because shadows don't do anything. They're not a physical thing. You need some other hand-wavy magical ability to make shadows into a tangible object to make them do anything whatsoever. I mean, I know the idea of shadow control is cool for all you teenage edgelords out there, but it's a nothing scientifically. I know the idea of shadow control is cool for all you teenage edgelords out there.
And it's still cool. I'm coming at you. So I just gotta ask you, what about antiphotons?
But let's talk about this. Let's talk about photons and antiphotons, which are just photons. I'm gonna use the item label stuff to help me out here. So you got matter, you got antimatter. When they come in contact, they annihilate. And photons come out. That's because photons aren't anti-anything. They have no charge. They just exist. The reason why the math works both ways is because both ways you end up getting photons. Photons are their own antiparticle. That's pretty cool. Now, here's the weird thing. When matter and antimatter annihilate, all the energy, all the stuff that made that matter has to go somewhere. It goes into the electromagnetic spectrum. If you could create some kind of antiparticle, like an antiphoton, like just theoretically, all that energy in the electromagnetic spectrum has to go back into some other quantum field. Which means if you could find an antiphoton, if you could find something that would annihilate with photons, the result would be stuff. So in that way, maybe you could look at whatever shadow manipulation is doing as annihilating photons to create stuff. Problem is that stuff would probably be created equally in matter and antimatter, and it would be pretty explosive. So you probably wouldn't get the cool, Shikamaru, shadow hold stuff that you're going for. That is one way, mathematically, to maybe make it work out. But again, that's more theoretical fantasy, science fantasy than you might think, because photons in the real world are their own antiphotons. They're themselves. Anyway, follow me for more nerdy science stuff, and if you want your own particles and antiparticles, go to the link in my link tree to item label and use code RPG for 15% off. Yeah, this is why antiphotons are more science fiction than science, or at least the sort of fantastical idea of antiphotons that we talked about in the thought experiment. In the real world, photons are just their own antiphotons. They have no charge, so if you were to reverse their charge, you just get a photon again. So they don't annihilate with themselves when they come in contact with themselves. The thought experiment was to think of a particle that would annihilate with a photon the way that matter annihilates with antimatter, and yeah, then you get this kind of recursive loop. And that is one of the reasons that we don't see particles like that in the real world. You basically have a situation where no matter and energy would ever be stable enough to exist. Instead, you have our universe, which basically has this process by which matter and antimatter cancel each other out and release all that energy into electromagnetic energy, which is photons. And once you get to photons, that's it. That is a very stable state. Unless any huge breakthroughs come out of particle physics, which, always may happen in the future, that's where the buck stops. You're not really going to get a whole lot by smashing photons into other photons. They generally do not interact with each other and they pass through each other uneventfully. Follow if you want more nerdy science stuff. Isn't controlling shadows just controlling light? I mean, kind of. There really only are two superpowers, quantum manipulation and space-time manipulation, so this is quantum manipulation, so sure. But each superpower has its own limitations, so I guess you could just choose where photons aren't. Which, could be pretty powerful in its own right. Depending on how far your reach goes, if you just go photons aren't on Earth, the Earth's gonna freeze to death. There's still gonna be geothermal activity, but for all intents and purposes, it's gonna freeze to death. There's a bunch of other cool stuff you can do too, like Wi-Fi and radio and cell phone signals are all made of photons. So you could just deny everybody service. You of course could blind people. You'd be really handy on a film set, you'd get the lighting exactly how you wanted. But really, I think the denial of service thing is going to be the coolest thing you could do here. I mean, imagine what you could do if you could just make everyone's cell phone. How far can you push the ability to shrink and grow like Ant-Man or the Atom if you took all of science into account? Probably not very far. So here's the thing, when we're taking all of science into account, we're taking the drawbacks too. That's why people with water manipulation couldn't just manipulate any other liquid. So if you grew giant like Ant-Man, the square cube law would kick into effect, your volume would increase much quicker than your surface area. Your bones and muscles wouldn't be able to support yourself, you wouldn't be able to circulate blood through your body, and you'd die. So growing giant, not super useful. Getting small, probably a lot more useful, but it wouldn't actually increase your strength or anything. And if you shrunk down to quantum size, well, you'd also probably die, because then just like a photon bouncing off of you would like interact with you and change you in some way. Now that being said, who remembers when Infinity War and Endgame first came out, and we thought about how Ant-Man could kill Thanos by climbing up his butt? That would be scientifically possible, and is probably the best use of that power. Science. I'm sure this video has made my sponsor item label proud. Check out the link in my bio if you want one of these plushies. Is it scientifically possible to shrink things? I mean, depends on the scale you want to shrink it. You've seen things shrivel up when you dehydrate them. That's a type of shrinking. Of course, you said, is it possible to shrink living things and keep them living? Not to a particularly high scale. I will say this though, you are shrinking and growing basically every day. Over the course of the day, gravity weighs down on you, and that actually compresses the spaces in between your bones. And then, when you sleep horizontally, those spaces decompress. So in the morning, you're a little bit taller than you are in the evening. And I guess that's a form of shrinking. But if you're talking about like Pym particle stuff, yeah, there's no way that you could do that. There's no like Honey, I Shrunk the Kids condense atoms using their empty space sort of method of shrinking a normal living being down into a smaller version of that normal living being. Which is weird, right? Because of all these scientifically plausible things in fiction, which are like many and vast, like magnetic manipulation or like moving the heavens and stuff like that, shrinking is actually one of the least plausible things, one of the most fantastical things. That's kind of interesting to me. How far can you push vibration as a superpower if you consider all of science? Well, the question here is, what do you mean by vibration? Because if vibration you mean any back and forth fluctuation, well, everything that exists is just fluctuations in quantum fields, vibrations in those fields. So if you can control all of vibration, you could make matter and energy come in and out of existence. It's basically just complete quantum particle manipulation. It's super busted. In fact, if the graviton is real, then you control gravity too. It's just busted. If you only vibrate things that already exist, then you basically have complete control over molecular movement, which again, pretty busted. You could turn simple photons into X-ray radiation or lasers. You could vibrate the air to make sound illusions. Honestly, you could change the wavelength of photons to make light illusions too. You could vibrate the air enough that you create vacuum pockets that suffocate people. Or just create pressure waves that are the equivalent of massive nuclear explosions. You could make people freeze, you could make people spontaneously combust. I mean, all that exists is basically just particles that are moving in some way. If you control that, you control basically everything. If you like these videos, click the link in my bio to get one of these guys. It really helps me out. If you take all of science into account and you had solar powers, could you theoretically create gravity? Probably not. Here's the thing. Gravity is created by mass. Mass bends space-time around it, and that bending of space-time is what we call gravity. Solar powers, keyword solar, sun, tend to have to do with light. Light is photons, and photons are one of the only particles that don't have mass. They don't have the one thing that is required to create gravity. Now, there is very young science that talks about changing photons so that we get heavy photons that are slower, but they basically have to bond to non-photonic particles. So I don't think that this would be in your power set, but if you could like slow things down, make like light constructs like Green Lantern, those would have mass, and maybe you could create gravity then. But that's stretching it a bit. In general, if your power is light, light has no mass, no gravity. If you like videos about science and superheroes, give me a follow and click the link in my bio to check out my sponsor. It really helps me out. How far can you push fire manipulation as a superpower when you take all of science into account? Well, it's actually not that hard. The first question, can you manipulate heat? If you can cause ignition, you probably can. While manipulating heat is manipulating atomic movement. And manipulating atomic and molecular movement is very powerful. Like, we're talking screwing with the actual building blocks of reality powerful. Everything else gets less powerful from there. A lot of people think of fire manipulation as plasma manipulation, but fire isn't all plasma. But if you think about it that way, then there's elements of electricity manipulation you could do in there. You could control the power of the stars. Most of fire is in fact matter, not energy. It's fuel that's burning. And if you can manipulate that, you're manipulating matter and energy. Condense it enough, you control gravity. If you can control the transfer of heat, you can make other things cold. Really, the possibilities are limitless. Question is just, how powerful do you want your superhero to be? How far could you push water manipulation as a superpower if you take all of science into account? So, believe it or not, water is a little bit harder to break as opposed to fire, which I did in my last video. Fire doesn't really have any one chemical composition. It is just the act of combustion. Lots of different materials at lots of different energies can combust. We do, however, know the chemical composition for water. It's H2O, that's it. And if it's just water manipulation, you have to decide, does that include ice? Does that include water vapor? If not, then there's only a very specific range of temperatures that you can manipulate H2O in, between 1 and 99 Celsius. So water is strangely restrictive, more restrictive than the other quote-unquote elements. You could still do, like, a ton with it. Most living creatures are mostly water. You could snap your fingers, stop all the water movement inside a living being, and they'll just die. No blood flow to the heart and brain. And yeah, you could probably do a blood-bendy sort of puppetry thing, which does involve at least some control over plants. If you have enough knowledge of meteorology, you could control some sorts of weather. Couldn't, like, directly cause lightning to strike, but clouds are made of water. Like actual water, not just water vapor. Put the right clouds in the right spaces at the right temperature, and you can concoct a storm. It's worth noting that there are other planets and celestial bodies out there that have liquid water on them. One of them being the Earth. And while you probably couldn't use all the water on Earth to affect its orbit or something, you could very easily flood continents, cause earthquakes. There's also a lot of stuff on Earth that needs water to remain, like, flexible and pliable, so you could have a sort of withering touch by sucking the water out of them. Most fiction, when they break water powers, they kind of extend it beyond water to, like, ice or something like that. And, like, yeah, at that point you just have control of molecular movement, and that's just the same as fire manipulation. Except you could only control one molecule. But keeping it to just H2O, just in liquid state, you'd still be basically a god here on Earth. How far can you take air or gas manipulation as a superpower? Well, first you gotta ask, are we talking about air as in the stuff that is on our planet, or any gas? You could still do a lot just with the stuff that is on our planet. Increase and decrease air pressure, that's enough to kill someone. Easily fly, makeshift telekinesis, you could easily propel stuff with enough force to be lethal. I mean, that's all great, but if you could do it with any gas, now we're cooking. Because there's, like, dissolved hydrogen in seawater, which means you could just lift that hydrogen out of the seawater, ignite it, and then boom. You would take something like helium and increase its pressure to get it into its liquid phase, which would create some of the most super hot and super cooled areas on the planet. Also, since people always want to talk about doing this on a planetary level, most of the biggest planets are gas giants. And while stars are primarily plasma, there's gas there too. I mean, other than plasma, gas is like the most abundant phase of matter in the universe. So you have control over the majority of the non-plasma matter in the universe. So, like, good on you, buddy. Honestly, these elemental powers are always way more powerful than, like, comics or media portray them. Because if you actually have, like, the ability to control all gaseous matter, like, people have gases in them. You condense all that gas into one part in a person's brain and basically kill them. That wouldn't make for particularly interesting action, though, right? So instead, characters fire air blasts at each other. How far can you push dairy manipulation as a superpower? Someone here has seen Misfits. You have good taste. So here's the thing. I'm going to consider dairy manipulation to be anything that includes lactose. At which point, yes, if someone ate something with lactose in it, you could control it inside their body and kill them. And anything you could do with a solid or liquid or gas can be done with solid, liquid, or gaseous versions of lactose. So it's a lot of the same tricks that you're going to see with water manipulation or gas manipulation or stuff like that. But here's the big kicker. All mammals produce milk. Even males are capable of producing milk. That's right, men can lactate, which means that men already have some lactose in their body. So you don't have to wait for someone to drink milk. You can just squeeze that shit out of their nipples and then kill them with it. Science. science.
Most cases, unless there's something crazy going on, Wolverine cannot get sick.
I don't know if Wolverine can be a carrier for diseases. Here's the thing. Wolverine's immune system is basically doing what our immune system is doing, but fast. Really fast. Your body always tries to fight against poisons and diseases. It just might not be able to do it effectively. Wolverine's is like nearly 100% effective. Part of fighting against diseases is making it so that you can't transmit it to someone else. Think if Wolverine's immune system is able to fight off an infection, that infection is likely not just sitting around in his system. It is effectively neutralized. Like when we heal from a cold, not every cold virus has been removed from our body when we've healed from it. We are no longer contagious. I think if Wolverine could heal from something, part of that healing is becoming non-contagious. Might be able to, design a virus specifically to take advantage of holes in his healing factor, but you'd need, Mr. Sinister to do that. Okay, this is such an interesting idea. The blood of Wolverine from the X-Men can be used as a poison. We know that Wolverine has a very active healing factor. That means that it's just doing what our bodies do, but better. Now, when you get an organ transplant, usually you have to take immunosuppressor, because the new body part and your body attack each other because it looks foreign. If Wolverine's blood contains his white blood cell, then those blood cells may look at another body that they're injected into as foreign. And since it can attack you better than your body can attack it because of its healing factor, Wolverine's blood may be the best poison out there. I know that that's not how it really works in the comics. I know that people who are injected with his blood get a healing factor of their own. But from a more scientific standpoint, you could use Wolverine's blood, even a small bit, to kill a whole bunch of people. Like, if it perfectly healed, even if just a small bit got on their skin, that would be a major problem. That would be an interesting thing to visit in future X-Men issues. What are some downsides to Peter Parker's spider sense? Well, the comic handles it pretty decently. I mean, first of all, it's vague. It just tells you that there is danger, not where it's coming from. And that's a pretty big weakness, but I think an even bigger weakness is gonna be the anxiety. Like the feeling that something bad is gonna happen, but you don't know what it is, but you have to deal with it or else you're totally fucked. That just sounds like an anxiety disorder. Spider anxiety. The problem with spider sense is that it's always true, unless it isn't, because Peter Parker's spider sense has misfired before. Or it's fired, but someone else handled the danger. So yeah, it sounds like the biggest downside to spider sense is you're gonna need therapy for all the anxiety. Also therapy for, being Spider-Man. It's like one of the worst jobs. If someone had the ability to control all forms of energy, could they basically do alchemy Full Metal Alchemist style? Well, it depends on what you mean by all forms of energy. Relativity teaches us that mass and energy are basically the same thing. So if you allow for that, controlling all energy means you're controlling all mass, and you're already there. Scaling back, you could say you could control all fundamental forces. At that point, you're controlling the very forces that make particles happen, so still, you could do it. Heck, even just controlling kinetic energy would be enough to move particles around, at which point you could do Full Metal Alchemist style alchemy. So in short, you don't need to control all forms of energy. You don't even need to control most forms of energy. If you can control a form of energy, you're probably most of the way there. That's why most comic book superpowers have to be limited in some arbitrary way, or else basically every superhero you know would be a god walking upon Earth. Like, even the ones that you wouldn't think would be gods. Like, think about Wolverine. Think about how fast Wolverine heals. Where's that matter coming from? Futz with that enough and you get Andy from Undead Unluck. Okay, you want me to explain the science of negating from Undead Unluck? This is not as complicated as I think most people would assume it would be, but that's just because I'm taking this from sort of an abstract standpoint. Science, our goal is to always ask why and have the answers to that question fit with our observation. Eventually, science hits a boundary that they have to try and push past somehow. Like, we know that there are so many fundamental particles, but we don't really know why there are that many fundamental particles and not more or less. We are very vague about the conditions of the very early universe and why it made our universe the way it is. Undead Unluck answers that question for us. After we get past the subatomic level, there is the level of rules, which act as a sort of prevalent field. That field extends beneath the quantum fields that we know about physics right now. By altering the attributes of that field, it alters the way that all the other fields in the Undead Unluck world interact with each other. You've already seen one of those rules in the anime. You've seen spoil. Because spoil exists, the chemical reactions that allow things to decay also exist. As long as this field of spoil extends throughout the Undead Unluck universe, then things will decay. Now, why am I calling this a field?
Because in physics, when we describe things as a field, we also get to describe whether or not things interact with them. Photons, for example, do not interact with the Higgs field. Thus, I would say that negators are likely made up of a type of matter that mimics our own, a lot like matter and antimatter, but their one exception is they don't interact with one specific rule field, which, interestingly enough, gives us a glimpse at what the Undead Unluck universe looked like in its primordial days, before there were many rules about. Like, not only would you be able to live forever, but you could really easily clone yourself, create energy out of nowhere. Like, the only thing keeping the laws of physics acting like they should are these rule fields. But since each negator negates one rule, they simply do not interact with those fields and operate in respect to those fields as the primordial universe would. That's a whole lot of science lingo for a horny action anime, but that's what I got.
Energy accumulation in anime always comes with weird sound effects. Is that the case in real life? You mean like in Dragon Ball when they power up and they go whoosh, 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 stuff like that? Anyway, long story short, yeah. Thing is, nearly everything makes a sound. Sound is just vibrations in air. So if you have anything that ejects energy into the air in any way, it's going to make a sound. And you've seen this in real life. Ever turn on a light bulb and hear a hum? That's accumulating energy making a sound. Ever hear a high-pitched whine when you turn on an amp? Or if you're really old like me, when you turn on a CRT TV? Presumably, when anime characters gather energy, that energy is moving through something. That something being the air, the rock around them. I mean, in DBZ, we literally see the earth move when they do it. And if the earth's moving, the air's moving, and if there's movement, there's sound. Now, what sound would it make? That depends on how the air vibrates, which is going to depend on the frequency and amplitude of the sound wave, which is going to depend on how the air molecules move when you move the energy through them. There's really no way to tell without knowing, like, the physics of ki or whatever, but I personally am partial to the Mega Man X Mega Buster charge sound, so I'm just gonna go with that. Isn't the Kamehameha made out of plasma? From a scientific standpoint, I would have to say no. Plasma is super hot. I mean, the sun's basically made out of it. And that heat radiates. So if like a Kamehameha was made out of a plasma, or if any ki blast was made out of plasma, then that heat would radiate around it, and it would be doing things like setting grass on fire, setting trees on fire, melting metal, and that is just not what we see when someone in Dragon Ball fires a ki blast. Rather, it appears that ki follows fluid dynamics and operates mostly in the same way as like if you could control water. It's primarily an impact force, but if you can narrow it down to a single point of pressure, it can create a drilling force. And at high enough speed and output, the friction of it can wear away stuff and burn stuff. But if it were plasma, it would burn a lot more and impact a lot less. So I think it's pretty safe to say that whatever ki is in the Dragon Ball universe, it is not actually a state of plasma. At My Life as an RPG, how fast would a human have to spin to levitate like this? Levitate like what? Hold on. Oh, I see. Yeah, Ultimate Muscle's kinda crazy. Well, long story short is you can't. When you spin normally, the forces of lift and any other forces just cancel each other out, because human arms and legs are not very aerodynamic. But let's say, for argument, that you could flex your muscles in such a way that they would basically become helicopter rotors. A helicopter will spin its rotors like 500 times a minute, but it's big. It has a huge wingspan, rotor span, whatever you want to call it. Tinier drones have to spin like 3,000 times a minute or more. Now, believe it or not, people have done this math before, and for a human arm span, we're looking at like 2,000-ish revolutions per minute. But the interesting thing here is that he's flat, right? His whole body's basically the rotor. So you could probably get this down quite a bit. The only problem is there's nothing stabilizing him. There would be no way to control himself unless he was also able to flex to change the angle of whatever position his muscles were in, at which point he could basically self-correct and lift off with a lot less lift that a normal helicopter would need to. So if we assume his body is a perfect shape, and if we assume that it's getting the same lift as a helicopter rotor, and we assume he weighs average human weight, we're looking somewhere between 1,000 and 2,000 revolutions per minute. And once you get to 3,000, you're getting close to breaking the sound barrier. So I guess it's a good thing that he's not going to die due to sonic boom, but his muscles have to be really powerful to not be ripped off just to centripetal force.
Can I think of any downsides for infinite strength as a superpower? Sure, it's not even that hard. First of all, your strength may not sync up with your body's ability to absorb damage. MHA did that. Second, your strength may not line up with your ability to control said strength. Actually, MHA did that one too. I think the most unique thing I could say is that at high enough levels of strength, the laws of physics aren't going to behave the way you think they do. You're not just going to hit something harder or make something break apart. You're going to, generate heat. Remember, your power, your force, is a function of your mass and your acceleration. So you're either going to have to make yourself move really, really fast over a very short distance, or to increase your power, you're going to have to make yourself more massive somehow. Both of those come with their own problems. The speed of light being your speed cap, and black holes being your mass cap, effectively. And while punching so hard you create a black hole sounds badass, it's remarkably less badass if you end up, stuck inside it forever. If you want me to do the science of how devils work in Chainsaw Man, that's a tough one. It's not exactly known for being a series that steeps its power sets in science, Alright, absolute bullshit mode activate. So the first important thing, blood. We see that Denji can't really operate if he loses too much blood. We see that Power can die, but she won't as long as she gets more blood. We also see that most of the devils that are just out fucking shit up are looking for human blood. This leads me to believe that devils are primarily made of blood. They are essentially blood constructs. Most of their matter is made of blood. This is why fiends and hybrids are so powerful. Hybrids, like Denji, basically just have equipment to manufacture blood in their body. All those bones and whatnot. So as long as Pochita's demonic heart is still beating inside Denji, it just uses its demonic power to kick his bone marrow into overdrive and regenerate from anything. Power likely undergoes a similar process, but the problem is Power is canonically a corpse. All fiends are. So presumably she can't make blood as efficiently as Denji can. I mean, Denji was pretty dead in episode 1, but he was freshly dead, so you could say that a lot of his tissue was still alive. This will explain why so many devil contracts end up having you give up parts of your body. Human flesh, human cells, better utilizes human blood for metabolic processes, which means that wild demons just need to keep feasting on human flesh and blood. Now, as long as someone fears whatever a devil is a symbol of, then it can regenerate. But we see later in the manga, they don't necessarily retain their memories, especially if they have to regenerate back in hell. So this is probably something similar to the way the immortal jellyfish regenerates. It's total reversion to a larval state. In fact, they may leave some of their cells in hell specifically to do this. The whole fear thing is really hard to science without getting into dumb magic mumbo-jumbo, but we already have to believe that communication at a distance is possible in this world in some way. For example, the gun devil's pieces know to try and get back to its body. So okay, thoughts go through the air, there's not a whole lot we can do about that. But given that stipulation, you could think of devils utilizing their power as a processing problem. They have all this matter and energy that they could do nearly anything with, and so their power is only limited by having a brain, a computer essentially, that can manipulate all this matter and energy to do what they want. And since we've already accepted that thoughts are kinda just in the air in this universe, whatever bandwidth fearful thoughts are broadcasted on can be the same bandwidth that devils use to enact their powers. More fear of that devil, more bandwidth available, more powerful devil. I gotta be honest, a lot of times it's fun to apply science to anime series like this. That is not so much the case with Chainsaw Man. This is honestly one of those series that's probably best left to being, it's devil magic, bro, and that's it. Enjoy the religious symbolism and go on from there. But do watch it though, it is an amazing series. And read ahead in the manga if you really want to be traumatized. So this is an interesting question. If luck manipulation, or causality manipulation, were a superpower, how could you explain it scientifically? And, it's kind of hard to do. Because, in physics, there really isn't anything as luck. There's either the super deterministic model, which states that everything that's going to happen was going to happen because you could trace its causality all the way back to the Big Bang. Or the many worlds model, which states that there is some probability in quantum events, but each possible outcome has to happen. And since each possible outcome has to happen in one of the many quantum worlds, again, there's really no chance. So I think this means if you were going to scientifically explain luck manipulation, the best way to explain it is it's a scam. Or perhaps some form of limited future sight that your brain tricks you into thinking was directly caused by you. Because either way, scientifically, whatever was going to happen was going to happen. In superdeterminism, its causes can be traced back to the Big Bang, at which point the luck manipulator says, oh, I want this thing to happen, but that thing was going to happen anyway. Or in many worlds, the luck manipulator would go, I want this thing to happen, and in one world it would happen, In another world, it wouldn't, so either their power would fail, or in that world, they didn't want it to happen. That's the best I got.
Trash manipulation as a superpower. Garbokinesis. I don't have much to say about it scientifically, but semantically, there's an interesting issue here. Because I don't think you could use it for anything other than taking out the trash. If trash is defined as something that no longer has use, just refuse, then as soon as you used your trash manipulation powers to, say, levitate a trash bag and throw it at someone, they would stop, because it's no longer trash anymore. Now it's a useful weapon. The only action in which you are using trash and it remains trash is taking out the trash. So you could use your garbokinesis to help you take the trash out, but you couldn't do much else. But you know, I'd still take it. Taking out the trash sucks. Luck manipulation is a lame superpower, and here's why. Flipping a coin isn't luck. Flipping a coin is basic physics. That coin has weight. When it tumbles through the air, there's air resistance. There's an initial force that you're giving it. If you knew all those forces involved in the coin flip, you would know what its result is 100% of the time. And if you had perfect control over those forces, even just perfect control over the forces in your thumb, you could make it land that way 100% of the time. And in fact, there are street magicians that can basically do that right now. You can train yourself to flip a coin so that it always has the result you want. There's no luck in it. It's just basic physics. Even if you just flipped it as hard as you can, it's just basic physics without you knowing all the information. So if your superpower is to alter the outcome of that coin, basically you just have the weakest telekinesis that I can imagine. This Science of Superpowers video is brought to you by Item Label. If you want this shirt or any of these guys, check out the link in my bio. So someone asked me to apply science to the superpower of luck manipulation, and I find this comment super interesting. Because I originally said you basically couldn't, because luck doesn't really exist. You flip a coin, for example, there's air resistance, there's your initial force, there's a bunch of stuff that determines what side the coin lands on. But it's not random. You had perfect information, you could predict it, and sleight of hand magicians, right now, can train themselves to flip a coin in such a way that it lands the way they want it to. But a bunch of people brought up that luck is what we call outcomes we don't have perfect information for. Like, we don't have the perfect information for a coin flip, so we call that luck. We don't have the perfect information for the physics of a die roll, so we call that luck. And coincidences that go in our favor, we don't have all the information for what led up to them happening, so we call that luck. And so then, as this commenter said, luck manipulation is control over everything you don't know. Which is crazy. That's such a great way to describe that power. I love the idea, as one of my friends put it, it means that the more you know, the weaker your power is. So if you have luck manipulation as a superpower, don't ever study physics. Ever. Be as dumb as you possibly can. Be completely uninformed about everything around you. The less you know, the more you can attribute to luck, and the stronger your superpower is. You just manifest the power needed to get the results you need if you don't know what would create those results. That's stupid, that's broken, and you can have so much fun writing that. That's great. That's a great idea, and I guess I agree with that scientific interpretation of luck manipulation. It's really cool.
So there's an old mathematical saying, the only probabilities people understand are 0%, 50%, and 100%. And I think that is the only reason people think luck manipulation is cool. Because if you really think about it, how could you ever know that probability was altered? Because just because something is improbable doesn't make it impossible. So if a superhero had luck manipulation and they said they did something to make something improbable happen, how would you know? That was a possibility in the first place. It could have just happened. People might argue, well, if improbable stuff keeps happening, then that's proof of luck manipulation, right? No! Mathematically, the most improbable things happening over and over and over again are still a possibility. Somewhere in the infinite universe, the most improbable things are happening back to back to back to back to back. It's not common, but it's possible. So again, there's no way to tell if a probability-altering power was ever really used. There's this phenomena where if you ask people to arrange data in a way that looks random, they tend to evenly distribute it. Like if you ask someone to arrange coins in heads or tails to make it look like they were flipped and random, they will make them about equally heads and equally tails. But the thing is, every coin is equally likely to land heads or tails.
Really, if you think about physics, it's 51% one or the other, but still. Which means actually randomly generated data has these long streaks of heads or tails that people fundamentally look at as not random. These long streaks of heads or tails, which we think are inherently more improbable, are actually quite probable. So if your superpower isn't making the impossible happen, but just making the unlikely happen, there's a baked-in chance that that would have happened anyway. And so there's no way to tell whether or not you're actually using a superpower. And if you can take something that has 0% chance of happening and make it happen, then you're not really manipulating probability, you're just changing reality, you're just altering the world. You're breaking the laws of physics. So yeah, luck manipulation only seems cool because as humans, we're not really psychologically equipped to understand probability. We generally treat low probability as impossible, high probability as definite, and anything in the middle as equal chance. So unless you're able to travel back in time and iterate the same events over and over and over again, there's literally no way to tell if a luck manipulating superpower did anything at all. So I did a science fiction video talking about luck manipulation, and the big problem with applying science to luck manipulation is that there really isn't such thing as luck in science. Now, a bunch of people talked about how in the many worlds theory, there's a bunch of different timelines, and you could be using luck manipulation to select the timeline you're in. But here's the thing. There is no real selection of timelines happening. If the many worlds interpretation is true, it's not like you're traveling down a timeline and then you eventually decide randomly which fork to go down. Rather, there has to be a you on every fork of every timeline. So the you that is experiencing this timeline isn't special in any way. You didn't decide to be in this timeline. Rather, because of the way many worlds works, there necessarily has to be a you in this timeline and has to be a you in every other timeline that includes you. You are not experiencing what you are experiencing now because you chose to go down this timeline, or even because random chance put you down this timeline. You're experiencing what you are experiencing now because you are the version of you that exists in this timeline. So if luck manipulation let you choose what timeline you're in, again, that's really just kind of a scam because you aren't choosing anything. Even if you chose the best possible timeline for you, you are experiencing that timeline because there has to be a you experiencing that timeline. And there's also a you experiencing every other timeline. Which means if you use your power to get to the best possible timeline, nothing happens. There's still pseudo-infinite copies of you doing pseudo-infinite things in pseudo-infinite timelines. If you didn't use the power, nothing happens because there's still a best version of you in the best possible timeline living in that timeline along with all the other pseudo-infinite yous. So no matter what way you look at it, scientifically, luck manipulation just really isn't a thing, which is actually, I think, really cool. All luck manipulators are just on a timeline where the best possible shit happens to them and they call it a superpower. This would also account for why luck manipulation sometimes just fails and bad shit happens anyway. In my opinion, it's kind of crazy to apply science to a power like luck manipulation anyway, but you guys asked for it, so that's what I got.
So One Piece fans want to know how much lightning weighs, presumably because of this feat right here, where Luffy ends up throwing a lightning bolt at Kaido. And the funny thing is, as badass as this is, it's not all that impressive. But first we have to talk about what a lightning bolt is. A lightning bolt is a column of ionized air. Basically, charges build up between one point and another, an electrical discharge happens, and in the process it strips the electrons from the atoms of air. So you can generously calculate the mass of a lightning bolt as whatever the mass of the air it would normally take up would be minus the electrons. Luckily, someone already did this math for me, and that comes out to about 360 times 10 to the negative 10 kilograms, which is like nothing. It's barely noticeable. So Luffy isn't putting out any great feats of strength by hurling that lightning bolt. So of course, then people will say it's a great feat because he's in Gear 5 and that allows him to use his imagination to fight however he wants. Thing is, if he were a little bit smarter, he could have done this without Gear 5. Because we've captured lightning with our own technology before. And you know where you could find it? At the Hot Topic, in the mall. Lightning simply cannot travel through good insulators, and rubber is a magnificent insulator. And since Luffy's body is made of rubber, all he would need is something conductive to channel that lightning bolt through, and just by the nature of physics, the bolt wouldn't hit his body, it would travel through that conductive material, and then hit the next available target. This can be like a glove made of metal or something. And we've done that too. This is engineer Alan Pan doing his best Chidori using a conductive suit. By the way, you should follow Alan Pan, he's amazing. But by using a combination of insulators and conductive material, the electricity in this situation will flow in and around the suit and not through Alan Pan's body. And he doesn't even have the benefit of having Luffy's rubber body. So yeah, from a scientific perspective, chucking a lightning bolt is one of Luffy's least impressive feats. But I mean, it looks cool. And in anime, isn't that what really counts? Why are the summers and winters so extreme and unbalanced in Game of Thrones? My best guess is that they're in the Goldilocks zone of a binary star system. Goldilocks zone is the point at which planets can orbit that it basically creates conditions that are habitable for life. If you had a planet that passed between the two stars, and the heat from both stars was just enough to make it habitable the way that our summers are, you would see a summer that lasted years. You would also see a winter that lasted years, and a very harsh winter when you were furthest from both planets. Only problem, you don't see two suns in the sky in Westeros. But maybe we're overthinking it. Maybe it doesn't need to be a binary star system. Westeros is only a couple continents as far as we've seen, which means it's entirely possible that whatever sun they're orbiting gives off a lot more heat and is much further away from them than our sun, which means that whatever planet that Westeros is on would have a much longer precession around its sun. This would result in there only being one sun and winters being very long and summers being very cold. We call a year one rotation around the sun, but maybe in Westerosi culture, it's just different. A year to them is a certain number of days, which has to do with how fast their planet spins, and a year doesn't necessarily encompass a full rotation around the star. Like if culturally we counted a year as 30 days, we would have several years of summer before we had a year of winter. So yeah, I think that's probably the more reasonable explanation than binary star system.
If you're a necromancer, does it count as necrophilia?
I can't believe I'm doing this video.
Alright, so let's dissect the word necrophilia. Necro means dead. Philia denotes fondness, usually an abnormal fondness, so in this case, fondness for the dead. Many people use the word philia to mean sexual attraction. That actually doesn't always need to be the case. Now, two things. Number one, to be a necromancer, you don't necessarily have to be fond of the dead. In fantasy settings, necromancers are often depicted using the dead more as tools, more emotionlessly, than having any particular fondness. That said, if they did have a fondness, then you wouldn't particularly think it would be an abnormal fondness, since their trade has to do with the dead. So, in the most literal sense of the word, no, it probably doesn't count as necrophilia. There's also the question of, are undead things actually dead? There's a reason why we have another prefix there, un, as in not dead, as in another stage of life after death. Having a particular fondness for the undead would be some other type of philia. Unnecrophilia, anti-necrophilia, something like that. So in short, linguistically speaking, no, it does not count as necrophilia if you're a necromancer. That being said, please do not fuck a corpse. Start making a list. Do not fuck a chimp and do not fuck a corpse. I'm sure I will give you more guidelines in the future.
So scientifically, if two creatures can procreate and their offspring can procreate, then they are members of the same species. That's the quick and dirty definition. It gets more complicated, but it's what we're using here. So in fantasy settings where there are half-orcs and half-elves and half-dragons and tieflings and all this crap, does that mean that they are all the same species? Well, first, you have to take magic out of the picture. Because, I mean, D&D is a magical world, and these creatures are magical creatures, so it could be the magic that's making the offspring viable. If magic is out of the picture, then maybe? Because here's the thing, we often see half-human, half-elves, and half-human, half-orcs, but do we often see half-elf, half-orcs? If all of these creatures can procreate and produce viable offspring in any combination, so we're talking drow dragons, merfolk goblins, half tabaxi, half whatever that weird turtle race is, if all of these races can procreate and all of their offspring can then go on to procreate, then yes, it means they're genetically similar enough to be the same species, which would be really fucking weird. Now, it wouldn't be fair to call them all humans, kind of like how we don't call dogs wolves, but it would mean that they all evolved from the same genetic line. Now, here's the interesting thing. What if it wasn't the case that all these fantasy races could procreate, but just that they could all procreate with humans? If that's the case, if humans are the omnifucker, then that would point toward humans being the oldest evolutionary race. And dragons, elves, dwarves, tabaxi, so on and so forth are recent evolutionary offshoots of them. because they're still genetically similar enough to procreate from their progenitors, the humans, but not genetically similar enough to procreate with each other. But personally, my favorite interpretation is that we're all descended from dragons. First of all, because there are some D&D canons that say it, and everything does seem to be able to fuck and be fucked by a dragon. Plus, that means every Dungeons & Dragons game has both dungeons and dragons. It's just that you're the dragons. Although, when you think about how biologically compatible everyone is with mind flayers, actually maybe don't think about that.
Now this is a fun one, the science of the reality anchor technology from the SCP Foundation. And the SCP Foundation won't do that science, so I have to. And in a sense, you are right. It's kind of like being an observer in a huge double-slit experiment, but we have to talk about what that means. Observing, in quantum instances like the double-slit experiment, is just another word for interaction. You cannot fundamentally observe something without interacting with it, whether photons bounce off it or you observe it through some other means. Interaction always happens at a point, not like a wave. If reality warping abilities have any basis in science in the SCP universe, and they act as you're described here, then reality anchors would basically, for some certain area, send out some sort of radiation or pulse that interacts with every subatomic particle in the given area, somehow safely, which would be difficult. But the result, in a fictional sense, would be a constantly collapsed waveform. How you're going to do that to every particle constantly, I don't know, but that's how it works.
Would there be any downsides to moving faster than light? Well, this is difficult because usually when people move faster than light in media, they're not obeying physics at all because, you just can't in actual physics. But let's say that you could, like a theorized tachyon. Well, then you'd be moving backward through time. And just moving fast wouldn't allow you to create a whole body double out of new matter or something like that. So you would, by definition, have to do the same stuff that you normally did up to the point that you move faster than light, just backwards, in reverse. And that's not particularly compelling in media, so let's break more rules. So you can move faster than light, and the relationship between time and space doesn't exist. Well, if physics and gravity still work the same way, then to even get to the speed of light, you'd need infinite energy. Having infinite energy localized to a point where you're moving would basically destroy the universe. So then we have to break more rules. At this point, we've removed every relationship between space, time, mass, speed, force. Relativity no longer applies, gravity no longer applies. So in a world where none of the laws of physics apply, would going faster than light have any downsides? Well, you couldn't see anything. Because by definition, you're going faster than the light that would hit your eyeballs. For that matter, none of your senses would work. You'd be going too fast to breathe or smell. And I mean, technically you're going faster than the speed at which particles interact with each other. So I guess you could say you phase through yourself and turn inside out, but that may be just another one of the laws of physics that we're ignoring. So I think what I'm saying here is that the only way faster than light travel makes sense in a fictional context is if you wave your hands and say, fuck it, it just works. Which most fiction does, so, whatever. I'm back outside, back in the item label hoodie, back walking a dog, and now I'm back answering faster than light science questions. So your question, which TikTok has probably removed by now because it's acting really wonky about older comments, is would time dilation happen in sci-fi shows like Star Trek, where there is a warp drive that kind of hand waves away the laws of physics, and now you can travel faster than light? So here's the thing, sci-fi can hand wave away whatever laws of physics it wants, right? But time dilation isn't just this thing that happens when you get close to the speed of light. It's a consequence of the rest of the universe having a speed limit. Examine the infamous barn door problem. You go faster than light, you experience length contraction. But that's only for an observer. So let's say that a train is moving close enough to the speed of light that it can move through a barn, and the doors on either end can close and completely close it in, and then open again before it gets out. But at a normal resting state, it is too long to get through that barn while closing both of the doors. People on the train are always going to see the train as if it were in its resting state. And observers on the train are going to see its length contracted. So what happens? How does it get through the barn? Well, people observing the train see the train enter the barn, both doors close, both doors open, and then it leaves the barn. People on the train see the train enter the barn, the first barn door closes, the first barn door opens, the train continues through the barn, the second barn door closes, the second barn door opens. Those two events don't happen simultaneously anymore because time is dilated. Now here's the thing, if you hand wave away relativistic effects, you're not going to get any of those effects. So if you have something like a warp drive that lets you go faster than light, likely you're not going to experience any time dilation, or at least the stories won't make you experience because that's inconvenient to write around. No one wants you to do one warp jump and then like 100 years have passed from wherever you jumped from. Unless, the episode's really cool. But the weird thing, though, is that the rest of the universe still obeys the laws of relativity, which means weird stuff happens when, one person breaks it. For example, let's say you're not warp jumping light years away. Let's say you're warp jumping just far enough away that you could see where you warp jumped from. Well, you will have arrived there before the light that bounced off you at the moment that you jumped got there. And so if you were watching the universe play at normal speed, you would warp jump, and then you would look out the ship to see yourself warp jump. Further away you go, and the quote-unquote faster you go, the longer it's going to take that light to reach you. Meaning, as you watch the universe play out in normal speed up until the point that you warp jumped, you're seeing further back into the past the faster you travel than light. And that's why sometimes it's said if you could travel faster than light, you'd be moving backwards in time. Because now let's think about this in reverse. Let's say a star is going to explode, and the crew of the Enterprise is going to stop it. I don't know, don't criticize me, I don't write for Star Trek. If I did, I'd have a lot more money. That star is going to explode in a month. But it would take thousands of years to get there at sublight speed, so you warp travel and problem solved. But now, let's make that exploding star the Enterprise. The Enterprise warp jumps away and then looks back to the point where it warp jumped. Time plays out at normal speed. But when they look back, they see a bomb strapped to their ship that will explode in a month's time. And if it could only be diffused at that location, if they solved it the same way they solved the exploding star problem, they're just gonna warp jump there, and everything's gonna be fine. But now there's essentially two instances of the Enterprise, and one of them has traveled back in time. So that means when the Enterprise warp jumped to that star, they also traveled back in time. And essentially, any faster than light movement is doing the same. So there's no relativistic time dilation as we know it in sci-fi universes. But since space and time are one fabric, they are inextricably linked. Traveling through space at extremely fast speeds will always have really wonky time effects. Because let's say that the Enterprise warp jumps to a point that when they look back, they see far before they started to warp jump. The light still has to catch up to them. And then they warp back to the point in time that they see before they warp jump. Now, just by traveling between 2 points, they've traveled back in time. Repeat ad infinitum, and you have a free time machine. Well, free if you own the Enterprise, at least. Can I explain the concept of pocket dimensions? Well, you can come at this two ways. In fiction, pocket dimensions just tend to be some space outside of space. It's just a way to say that some things are bigger on the inside than they are on the outside. Bag of holdings, TARDISes, stuff like that. In science, we really only see these concepts of pocket dimensions in two places. In forms of string theory, in which there needs to be more dimensions in order to make the math work. And these dimensions would be so incredibly small, like there would be no physical equivalent to moving in the 3 dimensions that we have right now. Or in certain models of the vacuum bubble universe, which is pretty complicated, but basically it's saying that there can be small pieces of the universe detached from our own universe. Vast simplification there. These detached pieces of the universe would basically be like their own bubbles of space. But unlike string theory, in which the extra dimensions are super small, these vacuum bubble universes would be unfathomably large. So they're both pretty different from the concepts of pocket dimensions that we see in fiction. Now, mathematically, you could explain pocket dimensions via fourth dimensional spatial movement, which is a lot of words, but bear with me. If you don't think of the fourth dimension as time, and instead think of it as another dimension of space, then our entire 3-dimensional existence exists all on one point of a fourth dimensional axis. This whole 3-dimensional universe is one fourth dimensional point. Again, if you're not counting time as the fourth dimension, which is what physics usually does. In that case, if you were able to move in the fourth dimension, you would find an entirely different 3-dimensional universe with entirely different 3-dimensional space, which could also act like a pocket dimension that you see in fiction. But again, that's all math, and math isn't science. But if you do want to think about it scientifically, think about the fourth dimension as time, and it still works. At this moment, the atoms and the particles in the universe are arranged in a certain configuration. And if time is the fourth dimension, then I am moving forward through it all the time. At this moment, I'm in a park walking a dog. In about an hour, I'll be back home eating lunch. By moving through the fourth dimension, by time passing, I am now occupying 2 different 3-dimensional sets of space. At my current fourth dimensional coordinate, you could run into me in the park. In the coordinates an hour from now, you can't. And also, I'm on a planet screaming through the solar system, screaming through the universe, so the actual space that park takes up will have moved significantly. So yeah, if you think about it, time is its own sort of pocket dimension. And honestly, this makes me want to see a superhero that
stores and retrieves things from the past and the future. I think that'd be pretty cool.